All right, ladies and gentlemen, I just want to go over the review guide that I gave you yesterday. So you should have that review guide out and correct anything that you may have done incorrectly. All right, let's start with the domain. We have to assume that there are arrows there. All right, we know that that's going to go left forever, and we know that that's going to go right forever. So your domain is negative infinity to positive infinity, or all reals. Range, that's going to go down forever. So we start at the bottom. So your lowest point to your highest point, that's going to be negative infinity. And we know the highest that this is going to go up to is right here. This is the very highest point of this graph. And we're talking about y-axis here. So that is 1. And we're going to have a bracket, since that is a definitive point that we can put our pencil on and say, yes, it is in fact going to stop right there. All right. Increasing and decreasing. I told you guys to redraw your x-axis at the bottom. Going to label that negative infinity. Label this side positive. Do we have enough room there? Let's erase a little bit. And we'll label this side positive infinity. All right, then we draw a dashed line through everywhere that it turns, and you see we're going through -1 right there on the axis, x-axis. And so we'll write that, -1. Then we have it going through, I skipped one, but we'll go back and do it. That one's going through at 1. And then here's another one, another turn, going through at 0. Then we look at it. Let's start left to right. This is coming from negative infinity, and it's increasing all the way to this dashed line to -1. So we're going to say increasing. The next part of it right here is going downhill. So we're going to say decreasing. Then we're going back up right there. That is increasing. And then the last part of it, you can see as we go past this line, we're going down. And so that is down for decreasing. And so this writes itself now. The answer is there. From negative infinity to -1, it's increasing. From -1 to 0, it's decreasing. From 0 to 1, it's increasing. And from 1 to infinity, it is decreasing. So let's fill all that in. So increasing from negative infinity to -1, with a union in between because we have another portion that's increasing. 0 to 1. That's both of our increasing portions. Now our decreasing is decreasing from -1 to 0 and from 1 to infinity. So we'll fill that in. -1 to 0, the union in between. And that's just saying we have another one. And that is going from 1 to infinity. Correct anything that you may have gotten wrong when you did it yourself. All right, x-intercepts. We see that we have one right there. We have a bounce right there, which means it's happening twice. And then we have one more right there. Remember I told you to count the up-downs to know how many degrees it is. So up 1, down 2, up 3, down 4. So we know this is 4 degrees, or 4th degree, which means we should have 4 zeros. There's one there, 2 on the bounce, and 1 there. So let's mark our points. So we have 1 there. We're going to estimate, we'll say that's in the middle. That's obviously on the 0 right there. And this is in the middle. So right here, we'll call that -1.5. We'll call that a 0 twice, and we'll call that 1.5. So our x-intercepts are I'll just write it x is equal to. So x is equal to negative 1.5, comma, 0, comma, 0, comma, 1.5. We have 4 zeros. We have one at negative 1.5, 0, 0, and 1.5. Y-intercept, where is it cutting through? It's cutting through exactly right there at 0. And so our y-intercept is at 0. And so we'll just write that as an ordered pair. So 0, 0. If we were going to write these as ordered pairs, let's just go ahead and do that. That would be negative 1.5, comma, 0, 0, 0, 0, 0 again, and 1.5, 0. All right, relative max. That means it's not our absolute highest point, but just one of the turns. Okay, it can also be the highest point, but we know relative and minimum maxes are just our turning points. So here is a mountain, so we know that's a max. There's another mountain, so we know that's a max. And then here is a valley. You see it dips in there, so we know that that is a minimum. So actually, let's take care of our absolute maxes first. So if I put my pointer there, is that the absolute highest that this is going to go? Yes, it is. And so let's put a point there. Right there, we know we have an absolute max at negative 1, 1. So absolute max at negative 1, 1. We have another absolute max because this is also the highest point over here. So we know we have one at 1, 1. So 1, 1 at an absolute max. Do we have an absolute lowest point? Can we put our pointer on something and know that it's going to stop there and not get any lower? No, we can't. So we know that there is no absolute minimum. Okay. What about a relative minimum? A point that goes low but's not the lowest, or a turn in the graph that is a minimum. Yes, it is. It's right there, and that's at 0, 0. And then for relative max, remember those are just the turning points that are maxes. It can be the exact same thing as absolute maxes, and in this case it is. It's both of those points. So negative 1, 1, and 1, 1. Going on to in behavior. And so this says as x is going to infinity, so as we're traveling this way on x, when I hit the line, what's happening? I'm going down, so that would be down to negative infinity. As I'm on x, traveling along x to negative infinity, that's what this is saying. When I hit the line, I'm going to be going down, so that would be negative infinity. On even functions, they should match, because notice both these are going down, so the in behavior has to match. All right, the minimum degree. I just said that a second ago at the beginning of this. How do you know your degrees? You can count your pathways, your up, down. So up 1, 2, 3, 4. That would be, let's do that one more time because I feel like you guys don't understand that sometimes. So I count up 1 to the turn, down 2, up 3, down 4. That's a minimum degree of 4. The leading sign of, or the sign of the leading coefficient, that means, is it positive to start or is it negative to start? So let's see, if I had ax squared plus bx plus c, it's asking, is this out here positive or negative? Well, we know this right here, since that's a 2, and it has nothing to do with this, I'm just giving an example. Since that's a 2, we know it's an even function, and we know an even function by start should be up, up. before anything happens to it. If this was negative, then this whole thing would flip and it'd be down, down. Well, we can see that this is down, down, so we know that it had to have a negative in front. And so to answer this question right here, we know that it's a negative. So all right, you guys probably didn't understand the symmetry here. It's just asking if it's symmetric, which means is any part of this symmetric. As you can see here, this side on the left side of the y-axis looks exactly like the right side. That's how we know it's even. That's another way that we know that it's even. And so we just write symmetric about the y. So symmetric on the y-axis. Let's continue along. Number 2. I'm moving fast because, again, like always, you can rewind this and watch it again later. All right, so it says, sketch a graph by hand given that the zeros are -3, -1, and 2. Then answer each of the following questions. All right, so guys, first thing, we look at this right here. We know a couple things. We know that this is the y-intercept because it's the constant, and we know that this is an odd function because the highest exponent is 3 there. And so if we graph our points, let's just say, so we have 1 and negative. It's too thick. Let's change that. We know we have -1, -2, -3. And so I know I'm going to also need a point at 2, so we'll put that there. So here's my point at -3. Here's a point at -1. And here's a point at 2. Now, our ends, we know that this is odd again because right there's a 3. And so we know by default, and I keep doing this because you guys, I want you to remember this. That's an even by default, and then an odd is down, up. So we got up, up, and then down, up. All right, so I should have a down, up unless this is negative in front, and it's not. So I know I should have a left side down, right side up. So left side down, right side should be coming up. And now I just count my turns, or my pathways going to the turns. And that should be 3 of them. So let's count up. We got up 1, down 2, and we should be going through -6, roughly down there, and then up 3. We know we're going through -6 because there it is right there. So we know that should be -6. And your function should look like that. Now we can do our domain. Domain on a function, we got arrows on both sides, so we know that's -infinity to +infinity, or all reals. How many zeros are we going to have? This tells us right here, 3, and we can see that there's 1, 2, and 3 right there. So we have 3 zeros. In behavior, as x is going to infinity, I hit the line and I go up. So that should be to +infinity. As x goes to -infinity, as we're going on x to -infinity, we hit the line and we go down. So that should be -infinity. The number of extrema. Remember, the number of extrema is the amount of turns, peaks and valleys. So mountaintop there, 1. Another one right there, that is 2. So we have 2 extrema. Another way to know it is you take the highest exponent and take 1 off of it, and that would be 2. So we have 2 right there. All right, continuing to number 3. It says determine the end behavior and maximum number of extrema, or the U-turns. So there's a U-turn, There's another one. There's 2. Or mountains and valleys. Let's do that down here. All right, so we see we have a 5 there, so that is odd. And we know we also have a negative there. And so left side down, right side up, that's if we don't have a negative. So we know in this case we should have a left side up, right side down, because there's a switch because of the negative that starts it. And so we should have 5 pathways to the turns. So it should be going down. Down 1, up 2, down 3, up 4, down 5. We know our graph should look roughly like that. Now we can do our end behavior. All right. As we're going on x to infinity, x going towards infinity, when we hit the line here, we're going to go down. So that would be to negative infinity. As we're traveling toward negative infinity, we hit the line and we're going to go up. So that would be positive infinity. And then extrema, you're just counting your turns. So that would be 1 turn there, 2, 3, 4. So extrema is 4. All right, ready to move along? All right, so we look at this one. Doesn't look like it's in standard form. So the first thing we want to do is put it in standard form. And that's putting it from highest exponent to lowest. So we know first we got this. That's the highest exponent. So let's just rewrite it right below. So negative 7x to the 4th. And then we have like terms here. So we have that and that. That's a 5x cubed minus a 3x cubed, which would be a positive 2x cubed. All right. And then last thing we have is just the constant plus, or wait, that should say cubed. Let's rewind a little bit. This should be a cubed. I had squared there. And then we have a constant of plus 12. Excuse me. So we have an even function. We know that because that's a 4 right there. Even start at up, but we know that this is a negative there, so it flips it. It'll be a down, down. And so we know we have left side down, right side down, and we have 4 pathways to the turn. So let's count it up. Up 1, down 2, up 3, down 4. Graph's going to roughly look like that. Now we can do end behavior. As x is going towards infinity, we hit the line, we go down to negative infinity. As we're going towards negative infinity, we hit the line, we go down again to negative infinity. Even function, and it matches. Extrema are turns. We have a turn there, 1, 2, 3. We have 3 extrema. Or take the highest exponent and subtract 1. So 3. Let's move along to number 4. Number 4, determine if the function's even, odd, or neither. When we're looking at just the function, we're looking at the exponents. If the exponents are the same, either even or odd, then we know it's either even or odd. If it's mismatched, then we know it's neither. So there's a 3 there. We know we have an invisible 1 there. Both odd numbers, and so that means we have an odd function. Let's go to the next one. We have a 2. We know we have a 1 there and a 0 there. So we see right off the top we have an even there and an odd there. We know this function is neither. exponents have to be either all even or all odd if it's going to be either even or odd. All right, moving along. Let's go to the next page. Here we are. All right, so it's saying state the range and the number of zeros for each of the following polynomials. So in looking at A, there's a couple ways that we can figure out the range. One, if you wanted to, you could go into the table, punch this in, and just completely just sketch out a rough graph, and that would help you to do that, to find the range just by looking at the graph. Or this is in vertex form, and so we know that this is H, and out here is K. There's no number, so we know that K is 0. So in vertex form, we have A x minus H plus K. And it's known as a vertex when you take H and you take K. But since H is inside the parentheses, we know it's going to be opposite when you take it out, and K would just be the same. And so when you take 4 out, the opposite of that would be -4 and 0. And that 0 is going to be very important because that tells you the value on Y. That's either the highest or the lowest. And so let's throw that all into perspective. And so a vertex, let me just draw something out to the side here. A vertex on a quadratic is when I draw my even function that looks like this. The vertex is the part where it makes its turn. So you can see on this one, on just a default parent function of a quadratic, just an even function, this point right here, the vertex, in this case, it would be a minimum. If you flip it upside down, it would be a maximum. Looking here, this starts with a negative, so we know that this has to flip. And so we know it doesn't look like that. We know it, in fact, looks like this, and the vertex would be up here. And we know what the vertex is. That's this point right here. -4, 0. Now we can, that's all we need to know. We can get our range at this point. So the very lowest that this is going down is what? Forever, right? So -infinity. And then what's the highest point it's going to? Well, as we go up, the highest on Y that we're getting is going to be 0. And so we know we have a 0 right here, and it's going to stop there for sure. All right, so this is our range. All right. Or, like I said, you can go on the table, punch in the exact function that looks like this, plot a graph, and then do your range based on that if you don't understand that. Okay, and then the number of zeros, that should be pretty easy for you guys. Because look, guys, there's 2 right there. That's the highest exponent. And so we know we have number of zeros is 2. Because it's your highest exponent. All right, let's look at this one. Less work on B. Right here, we see that this is an odd function. So, and there's no negative in front, so we know that we should have a left side down, right side up with 3 pathways. So up 1, down 2, up 3. We know we have a graph that looks something like that. Guys, we can get the range from that because this is going down forever and it's going up forever, which means range is -infinity to +infinity, or all reals. And then the number of zeros is our highest exponent, which is 3. So number of zeros is 3. There's our two answers. Sorry, my phone's going off. It's extremely late, guys. I'm making this video at 2:30 in the morning for you. So I'm up working, just as you can see here. And I'm still getting text. All right, so number 6 says state the sign of the leading coefficient. So we want to know if it starts with a negative or positive, and then if the degree is even or odd. Okay, and so this is left side down, right side down, so we know right there it's even. The sides match. And then the forgot what I was doing here. So it's even because it's left side down, right side down. And then the sign is negative because it's down, down. So it's flipped from up, up. So sign is negative. And an even degree. Even degree, sign, negative. Let's look at this one. This one we have in a down up, which we know all odds start with a left side down, right side down. So we know the sign is just positive. And then the degree is odd. If you want to count your degrees, start from the arrow, up 1, down 2, up 3. 3 is an odd number. Sign is positive because it starts down, up, and that's the default. Over here, we know it's even because, again, it's down, down. But then you got up 1, down 2, up 3, down 4. That's a 4. And that's an even number, so we have an even degree. Moving along to number 7, we have true or false questions. The polynomial, or the domain of a polynomial function, is always negative infinity to positive infinity. Well, yes, if it's a polynomial and it's a function, then yes, that would be true. That would be an arrow on both sides, which means it's going to go left forever and it's going to go right forever. The range of a quadratic polynomial function is always negative infinity to positive infinity. That's incorrect because I could have one that looks like this, and while that might go down forever, it's not going to go up forever, so that would be false. C, cubic polynomials never have an absolute minimum or maximum. And let's see, a cubic function by default would be left side down, right side up. And so if you look at it, we're talking about absolute here. Absolute, which means it's going to be the very lowest or highest points. Well, this is pretty high, but that's going to go up forever. And this is pretty low, and that's going to go down forever. Remember, your sides are always going to go opposite, and they're going to go forever, which means you can't have an absolute minimum or maximum because it's infinity. So this would be true because it's saying they never have absolute. So that is true. D, for a polynomial, is it possible to have a relative max and an absolute max? Yes, or it's saying it is possible, so that would be true. And we can use an example that I already wrote down right here. Because look, here is, remember, all terms are going to be relative. So that's a turn, so that means that would be a relative max because it's a mountain. But look, it's also an absolute max because I can pinpoint it right there and know it's not going any higher than that. Okay? Moving along. All right, let's look at 8. All right, a couple ways to do this. This is like what we just learned the other day for our first virtual day. This is right here, 4 terms. So we can do factor by grouping, or you can just go to your calculator and get the zeros straight out of your calculator. Okay. In this case, we'll just factor by grouping. I'm going to blow through this quick, guys. Just watch the steps. If you don't get it, just go back to the last video. So there. Take out GCF of that first set of parentheses. That would be x squared, which would leave me an x there, and it'd be a -3 there, which means I know if this is right, it should end up like that, and so I should have a negative, what's that, 1 right here is less than 0. Then I take what's outside the parentheses, put it inside, and then I condense those two down to 1. And then I can factor what's inside here. And so I know that should be in x plus 1, x minus 1, because it's the difference of 2 squares. And then I still bring my x minus 3 down. Probably should have done this in different ink, but it's a video, so, I mean, you got it. And so now I solve. I set each of these equal to 0 and solve them, which means they're going to turn into the opposite. So I got x, let's go a different color on the last step here. So x is less than 0. X, not 0. What am I doing? X is less than -1. X is less than +1. And then x is less than 3. Those are my zeros. So if I'm doing my graph, it's like so. We got a point at -1. And then we have a point at 1. And then a point at 3. So let's put our point at -1. Oh, that's going to be an open circle, since that is less than. It's not or equal to. So there's another point there, and another point there. And so we know that the highest exponent here is 3. There's no negative out here, so we know left side should start out going down, and right side should be going up. Our y-intercept should be at 3, +3, and we know we should have 3 turns. So up 1 through 3, back down through that, and back up through that. That's roughly what our graph should look like. So this is now telling us that all this should be less than, not equal to, so less than these points right here. So we shade the stuff that's less than that. So everything that's below the x-axis. So last step, interval notation. So we've shaded from coming from the negative infinity side to -1. So negative infinity to -1 union. And then we also shaded from 1 to 3. 1 to 3. And there's our answer. in interval notation. Let's do the next one. All right, so first thing, we got to get it in standard form. Let's do that. We're going to subtract 12x, subtract 12x. That leaves us with x cubed minus x squared minus 12x is greater than or equal to 0. And now we can pull out a GCF from this side right here because they all have an x. So we can take an x out. Inside the parentheses will be x squared. This would be minus x. And this would be minus 12 is greater than or equal to 0. Then we want to factor what's inside the parentheses. So I need a negative 12 on top, a negative 1 here, two numbers that multiply to get you negative 12, and then add or subtract to get you negative 1. That would be a 4 and a 3, a negative 4. So our factors would then be written out like x. And then remember to bring down that GCF. That's what I just did. X minus 4, x plus 3 is greater than or equal to 0. Then you set all that equal to 0 and solve, and that your x-intercepts would be, well, remember, you set this equal to 0, it's going to just be 0, and so x, guys, if you put equal, I don't care, because it's just telling you what your zeros are. X is equal to 0, a positive 4, and then a negative 3 once you get done solving all that. We graph. We see that our sign is greater than or equal to, so they're going to be solid points. And we know we're going to have 1 at 0, 1 at 1, 2, 3, 4, 4, and 1 at 1, 2, 3, negative 3. Odd function, so we know left side down, right side up, with 3 pathways. So up 1, down 2, 3. We're going to shade above because this is saying greater than. So shade above. Let's go red. Remember, or equal to means on the line as well. So the points that are zeros. Interval notation, we're shading from negative 3 all the way over to 0. So negative 3 to 0. Bracket that in because we're included those points. Union. And then we got 4 to infinity. And there is our interval notation. All right, number 10 is a little bit more complex. This is the difference of two squares. That's a perfect square. X squared is a square, and that's a perfect square. So how do we solve these? Remember, you take the square root of that, take the square root of that, and that gives us a 8x plus 9 and an 8x minus 9. It's greater than 0. So then you set both of these equal to, it's changing color. Both of these equal to 0 and solve. So minus 9 cancels. And then that leaves us with 8x is equal to minus 9 divided by 8 divided by 8 x is equal to a negative 9 over 8. Let's solve the other side. Let's just solve it straight from there since it's pretty much set up for us. So we have a plus 9, cancels. 8x is equal to, or greater than, doesn't really matter. Let's just to show you that it doesn't make a difference really, guys. Let's just leave that as equal. 9 divided by 8, divide by 8, that cancels, and then you got x is equal to a positive 9 over 8. So we have x is equal to a negative 9 over 8, and x is equal to a positive 9 over 8. So we can graph that. But how do we graph a fraction? Well, just enter the fraction into your calculator. So 9 over 8. Hit enter, and then hit the toggle button. And that tells us that this is equivalent to about 1.125. And so this would equal to, obviously, a negative version of that. Negative 1.125. And now we graph. Whoa. I just slid out of whack there. Can I undo that? No, I can't. Hang on. All right. Got it back. All right. So now we graph. So we got 1, 2, 3, 4. 1, 2, 3, 4. We know we need a negative 1.125. That's going to be roughly a little bit after, let's get the pointer, a little bit after a 1, so somewhere right up in there. And so we'll say, remember, open circle, it'll be right up in there. And then same thing on the other side, a positive 1 of that. So right there. It's an even function. And so we know we should have up, left side up, right side up. We know our y-intercept is negative 81, so we know it's going to be way down there somewhere. Back up. Let's just assume that's negative 81. And so now it's saying shade everything above because it's greater than. So red ink, shade everything except for the open circle. So it's not getting all the way down to the point. So we shaded from negative infinity to negative 1.125. So negative, that's an 8. Negative infinity to negative 1.125. And that is, or you know what? Let's just leave it as a fraction, guys. To negative 9 over 8. Both parentheses. And then union from 9 over 8 to infinity. All right, last one. Thank God, right? Thank God for me too, because it's late. All right, everything's in standard form. Can we factor it? I believe we can. Let's go ahead and do that. So we got our x there. Or you can just put in your calculator and get the points, guys. Well, no, on this one you might not. Yeah, you won't be able to do that. So let's see. We got that times that, which is a negative 72. And then you put b down here, which is 1. Now, excuse me, I need two numbers that multiply to give me that, and add or subtract to give me that. What would that be? It would be a, I need a pen, 9 and a negative 8, right? So that factor written out would be x plus 9 x minus 8. Remember, I multiplied by 3, so I got to divide back out by 3. Divide by 3. Divide by 3. And that would give me this, come on, thing. Simplifies down to x plus 3. And that one does not simplify down, so we do bottoms up. That would be 3x minus 8 is less than or equal to 0, and then we solve. We know that this x plus 3 is going to just simplify to, or not simplify, but solve out to x is equal to negative 3. And then let's just go ahead and solve this one. 3x minus 8 is 0. We got a plus 8 cancels. Divide by 3, divide by 3, and that gives us x is equal to 8 over 3. What does 8 over 3 look like? 8 over 3 is the same thing as about 2.67. And so now we have what we need to graph. And so let's do that. So we're graphing 1, 2, 3, 1, 2, 3. We know we have a solid point at negative 3. And then a solid point at about 2.67, so it's just before 3, so right there. Even function, so we know left side up, right side up, going down, back up through there. We're shading below because that's less than or equal to. So we shade from there, including the point, all the way to there. Our interval notation, we're shading from that point, which is negative 3. And we're including the point, so that's that bracket. And we're shading all the way over to, let's just use the fraction, 8 over 3, and that is a bracket. All right. And that's that. Any questions, hit me up, and I will help you out. Make sure you correct all the stuff on the guide that you did, because these are the correct answers. All right, that'll do it. Have a good one.